Good morning, everyone. Welcome to St. Joe Chemistry Class TV, WAEC Preparatory Class 2026. Today, we are solving WAEC theory past questions on mole concept. Here we go. Before I go into the questions proper, I would like you to understand that there are different expressions or formulas that are used to calculate questions that involve moles. And these are the formulas or expressions. Mole is equal to mass all over molar mass. Mole can also be expressed as number of particles all over Avogadro's number, which is equal to n all over n subscript A. Mole can also be expressed as volume all over molar volume. Now we go into the questions proper. For question number 1, calculate the number of moles in 10 grams of calcium triisocarbonate 4. CaCO3. Ca is equal to 40. Carbon, which is C, is equal to 12. And O, which is oxygen, is equal to 16. Now, this is the solution. CaCO3 is equal to 40 plus 12 plus 16 times 3, which is equal to 100 grams per mole. This means that molar mass of calcium triisocarbonate 4, CaCO3, is equal to 100 grams per mole. 100 grams per mole. Now, in order to calculate the number of moles in the question, the mass given is 10 grams. So mass is equal to 10 grams, and molar mass, based on the calculation, molar mass is equal to 100 grams per mole. Now from this, we can now calculate the number of mole. Number of mole is represented as N, which is equal to mass all over molar mass. All over molar mass. Okay? So by substituting, N is equal to 10 grams all over 100 grams per mole. 100 grams per mole. Now we have N, which is the number of mole, is equal to 0.1 mole. The unit of mole is MOL, which is mole. Thus, number of mole, which is N, is equal to 0.1 mole. Having solved the previous question, we move to the next question. And the question says, divide Avogadro's number. That's room of figure 1. Then room of figure 2. If 2.30 grams of an oxide of nitrogen contains 3.01 times 10 raised to 2 molecules, calculate the molar mass of the oxide. Na is equal to 6.02 times 10 raised to 23. That's the solution. For Roman figure 1, Avogadro's number can be defined as the number of particles present in 1 mole of a substance. That is, Avogadro's Avogadro's number is the number of particles present in 1 mole of a substance and the value is 6.02 times 10 raised to power 23. That's for Roman figure 1. Then for Roman figure 2, from the question, if 2.30 gram of an oxide of nitrogen contains 3.01 times 10 raised to power 2 molecules, calculate the molar mass of the oxide. Now, you need to understand what is meant by oxide. An oxide is a compound that consists of oxygen and any other element. So now for the calculation. The mass given is 2.30 grams. Mass given is equals to 2.30 gram. Then the number of nitrogen molecules is equals to 3.01 times 10 raised to power of 22. Then Na, which is the Avogadro's number, is equals to 6.02 times 10 raised to power 23. Now, the mole has to be calculated. The mole has to be calculated. And how can the mole be calculated? Now, mole is equals to N all over Avogadro's number, Na. Okay? Then N is given as 3.01 times 10 raised to power 22. So mole, which is N, is equals to 3.01 times 10 raised to power of 22 all over 6.02 times 10 raised to power of 23. By the time we use our calculator, we have 3.01 multiplied by 10 raised to power of 22 divided by 6.02 times 10 raised to power of 23. We have 0.05 mole. So mole is equals to 0.05 mole. But the question says calculate the molar mass of the oxide. Calculate the molar mass of the oxide. In order to calculate the molar mass of the oxide, using the formula N is equals to mass all over molar mass. molar mass. Now our N is equals to 0.05 mole, and the molar mass is unknown. The molar mass is unknown, and the mass is equals to 2.30 gram. Therefore, molar mass is equals to mass divided by the mole, and which is equals to 2.30 gram all over 0.05 gram per mole, which is equals to 46 gram per mole. So hence or thus the molar mass is equals to 46 gram per mole. You can see that mole is equals to 3.01 times 10 raised to the power 22 divided by 6.02 times 10 raised to the power 23, and the mole is equals to 0.05 mole. Then we could also see that N is equals to mass all over molar mass. Now N is equals to 0.05 mole. Molar mass is unknown, which is to be calculated. The mass is equals to 2.30 gram. So by substituting, we have molar mass is equals to, by substituting, molar mass is equals to 2.30 gram all over 0.05 gram per mole, which is equals to 46 gram per mole. Hence, the molar mass is equals to 46 gram per mole.
Go.
Now we move to the next question. And the next question is, deduce the formula of the oxide of nitrogen with the molar mass of 46 gram per mole. Deduce the formula of the oxide of nitrogen with the molar mass of 46 gram per mole. The atomic mass of nitrogen is 14 and the atomic mass of oxygen is 16. And this is the solution. Let the formula be NXOY. Then we now write an equation. We have, because the atomic mass of nitrogen is 14, now our 14x plus 16y is equals to 46, because the molar mass is 46 gram per mole. Now let x is equals to 1. Now when x is equals to 1, it means that we have 14 into 1 plus 16y is equals to 46. Then we have 14 plus 16y is equals to 46. From 14 plus 16y equals to 46, we have 16y is equals to 46. minus 14. Then we have 16y is equals to 32. Now divide through by the coefficient of y, which is 16. Divide by 16. Now 16y divided by 16 is equal to 32 all over 16. So 16 goes in 16, that's 1, and 16 goes in 16, that's 1. So then 16 into 16, 1, 16 into 32, that's 2. So we have y is equals to 2. Having known that x is equals to 1, so we have it in this way: x is equals to 1 and y is equals to 2. Thus, the formula of the oxide, of nitrogen is equals to NO2. NO2 of the oxide of nitrogen. Now we move to the next question. And the next question says, what volume of gas is evolved at STP if 2 grams of calcium trioxocarbonate 4 is added to a solution of hydrochloric acid? Calcium, that is, the atomic mass of calcium is 40, the atomic mass of carbon is 12, and the atomic mass of oxygen is 16. Atomic mass of chlorine is 35.5. The hydrogen atomic mass is 1. Then the molar volume of a gas at STP is given as 22.4 dm³ per mole. Now this is the solution. Now we need to write the equation for the reaction. Now the equation of the reaction, we have CaCO3 reacting with hydrochloric acid to produce CaCl2 plus H2O and CO2 gas. Now, the equation has to be balanced. Now, the equation is balanced. Now, from the balanced equation, one mole of CaCO3 produce 1 mole of CO2, that is carbon 4 oxide. Now based on the values given in the question, the mass, that is the reactive mass of calcium carbonate 4 is 2. So we need to calculate the mole of calcium triisocarbonate 4. Mole, that is NCaCO3 is equals to mass all over molar mass. By substituting N is equals to 2 gram all over the molar mass of calcium triisocarbonate 4 is 100 gram per mole. Therefore, using our calculator, N is equals to, that is, we divide 2 by 100. We have 0.02 mole. N is equals to 0.02 mole. The question says, what volume of gas is evolved? Now, this N, if N is equals to 0.02 mole of CaCO3, then the number of mole of the gas liberated, which is carbon dioxide of CO2, is equals to 0.02 mole, based on the equation of the reaction. So in order to calculate the volume, we are going to use the formula from mole is equals to volume all over molar volume. We now make volume as subject of the formula. So volume is equals to mole times molar volume, which is equals to 0.02 times 22.4 dmq per mole. Volume is equals to 0.02 times 22.4 dmq per mole, which is equals to 0.448 dmq. 448 dmq. So from the solution, we could see that our mole N is equals to 0.02. Then using the formula, mole equals to volume all over molar volume, we arrive at volume is equals to mole times molar volume, which is equals to 0.02 times 22.4 dmq per mole. And the final answer is 0.448 dmq. Thus, volume of the gas evolved is equals to 0.448 dmq. I will move to the next question. And the question says 5.6 gram of iron reacts with 7.5 gram of HCl according to the equation. We have iron reacting with 2 moles of hydrochloric acid to produce iron 2 chloride and hydrogen as a gas. The atomic mass of iron is 56, that of hydrogen is 1, and the atomic mass of chlorine is 35.5. And the question says, which reactant is the limiting reagent? Which reactant is the limiting reagent? Now, then the second question says, that's for number 2. Calculate the mass of FeCl2. Calculate the mass of FeCl2. That is, calculate the mass of iron 2 chloride produced. This is the solution. Now, from the equation, we have Fe, that is iron, reacting with 2 moles of HCl aqueous to produce FeCl2 aqueous and hydrogen gas. Now, this is a question that involves most in the aspect of limiting reagents. Now, according to the equation, 1 mole of ion of Fe reacts with 2 moles of HCl to produce 1 mole of iron 2 chloride, 1 mole of iron 2 chloride, and 1 mole of hydrogen gas. Now, based on the question, the emphasis will be on iron, HCl, and iron 2 chloride. For the first step, we are to calculate, having balanced the equation, we are to calculate the masses, the molar mass of the reactants. Molar mass of the reactants. Molar mass of the reactants. Molar mass of iron is equal to 56 gram per mole. Molar mass of 2 moles of HCl is equal to 2 into 1 plus 35.5, which is equal to 36.5 times 2, which is equal to 73 gram per mole. Having calculated the molar mass of 2 moles of HCl as 73 gram per mole, we now calculate their number of moles. So number of mole of Fe, that is iron, is equals to 5.6 divided by 56. That's 5.6 gram divided by 56 gram per mole, which is equals to 0.1 mole. The number of mole of HCl, that is hydrochloric acid, is equals to, we have mass over molar mass, which is 7.5 divided by 73. That is 7.5 gram divided by 73 gram per mole. I have 7.5 gram divided by 73. So we have 0.1 mole. As a result of this, based on the equation of the reaction, it means that 0.1 mole of iron Fe reacts with 0.1 mole of HCl, hydrochloric acid. Therefore, neither of the reactants is a limiting reactant or reagent. Now we proceed to calculate the molar mass, because we are going to calculate the mass of iron 2 chloride. We are going to calculate the mass of iron 2 chloride, and for us to calculate the mass of iron 2 chloride, we are going to make use of this formula or connection between iron and iron 2 chloride. That is 0.1 mole of Fe produce 0.1 mole of iron 2 chloride. From this, we can now calculate the mass of iron 2 chloride as. Now we need to calculate the molar mass of iron 2 chloride. Molar mass of iron 2 chloride. Molar mass of iron 2 chloride is equals to 56 plus 71, which is equals to 127 gram per mole. Therefore, the mass of FeCl2 is equals to, therefore mass of iron 2 chloride is equals to the number of mole which is 0.1, the number of mole which is 0.1 times 127 times 127, which is equals to 12.7, which is equals to 12.7 grams.
Go.
Thus, the mass of iron 2 chloride produced is equals to 12.7 grams. That's it for today. That's it for today on mole concept breakdown. We got more past questions to be treated during the next class. Subscribe and stay locked to Sir Joe Chemistry Class TV. Be blessed.